Yeah, thank you very much for the introduction. I will share my screen. Yeah, thank you. As was just said, this is the topic I'm researching for my master's, so I will talk a little bit about life cycle assessment and robotics. And yeah, let's just dive right into it. So as was just mentioned, let's maybe start from the very beginning to pick everyone up who might not be up to speed. So what is life cycle assessment? So life cycle assessment is a method that can be used to measure the impact of a product, process, or service throughout its whole lifetime. So when we're talking about robotics, we're usually talking about products, but it can refer to many other things. Often it is referred to processes. So this is used a lot in contexts of maybe biochemical processes and things like that. So what we mean by the whole life cycle is really from raw material extraction to manufacturing, to transport, to the retail or service provider, and then all the way to the use phase, disposal, and recycling. Obviously, these are a lot of steps inside the life cycle, so not all life cycle assessments have to cover the entire life of the product. There's shorter or more concentrated ways to conduct it. So the most popular ones are cradle to gate, which is displayed here, which is from raw material extraction up until the service provider. So basically until the product is ready to be sold at a store. And cradle to grave, which is from raw material extraction until the product is disposed. So how do you conduct LCA? LCA is a standard methodology. So these standards provide the way that this methodology should be conducted. And there are four main phases to it. The goal and scope definition, inventory analysis, impact assessment, and then the interpretation. So the four phases work in the following way. First, you define your goal and scope. And in this phase, you basically decide what the scope of your study will be. So this is what I just mentioned about, will this be a cradle to grave study? Will this be a cradle to gate study? What are the phases of your product's life that you're actually taking into account? Based on that, you conduct an inventory analysis. So you gather all of the inputs and outputs that you need for these life cycle phases. So if you're considering manufacturing, you might have your material inputs. You might have some electricity inputs that you need for manufacturing, maybe some water. And then as your output, you would get your product and maybe some waste materials. And then based on these input and outputs, you can conduct your impact assessment. So the impact assessment takes a few categories that you want to look at. So the most popular one, or the one that most people are familiar with, are is climate warming potential. So how many greenhouse gases are emitted by this process, measured in CO2. But apart from this, there's many more impact categories. And in this phase, you can say, okay, which are the categories I'm going to be looking at? And then based on the results, you can interpret these, see maybe there's a specific material that's having a specifically bad impact on your product, or a specific life phase that should maybe be thought about in a different way. And this can then influence your product development, and then you can restart your cycle. So it's a process that can accompany the entire product development stage. So this is the theory, but it's not really a very commonly used method in robotics at this point. So what is the problem? The problem is that mostly LCA is geared towards existing technologies. So the methods that exist assume that you have more or less a market-ready technology that you can then analyze. But obviously this is not optimal, because what you want to do is improve your product at the beginning of the development stage, when you have the most potential to change it. So this is where robotics has a bit of a challenge sometimes. If we look at this graph at the right, we have these two dimensions with technology maturity and market maturity. And robotics usually operates in this lower corner. So we usually have a low technology maturity, so we're having newly developed robots. And then sometimes we're either introducing these to markets where it's a very common thing. So we're replacing a technology that exists with just something new, or sometimes we're having completely new uses for these robots. So we're developing completely new things. And the circle sizes on this graph represent the uncertainty. So if we have a low technology maturity, we're going to have a big uncertainty on the technology side. And if we have a low market maturity, we're going to have a big uncertainty on the market side as well. So the higher the uncertainty, the harder it is to conduct LCA. Thankfully, there are methods to mitigate these uncertainties, though. So there is literature that focuses on how can we use this method, even if maybe we don't have all the information available about the product. So if we go back to the phases that I just talked about that are part of LCA, we can go through it and see, okay, for the goal and scope, maybe one of the challenge is that it's hard to define what life phases are we looking at for our product if we don't exactly know what these look like. So we want to look at manufacturing, but we only have a lab product. So we don't know what big scale manufacturing will look like. And what we can do in this case is to build scenarios. So if we don't know what the manufacturing or maybe the use case of a robot will look like, there are methods to develop future scenarios and think about what will it look like in the future based on my lab conditions. The next phase is the life cycle inventory, and sometimes we might not have all the data we need to provide all the inputs and outputs, or these might still be changing. And what we can just do is try to use proxy data, so data for similar processes or data from literature, from databases. And then on the parameters that we are most uncertain about, we can conduct sensitivity analysis. So we can vary these parameters to see how much this impacts our results. For the next phase, the impact assessment, we might have the issue that we might not actually know yet which impact categories might be relevant for our product, especially if we have a novel product that maybe, like we just discussed in the last presentation, might be using very novel materials that are not very researched yet. We might not know which categories might be relevant. So what's useful in this case is to just explore a variety of impact categories. So not just look at, for example, greenhouse gases, but say I have a list of impact categories and I'm looking at all of these, and maybe something will stand out to me that I wasn't expecting. And then the most important part is in the interpretation to be aware and be open about the fact that with early technologies, there are still a lot of uncertainties. These are not results that should maybe be taken as a quantitative assessment, but more of a help in the development. So it is giving more pointers about how I can develop my robot, but it is not a certain thing. And that needs to be communicated to everybody that's going to be looking at these results. So yeah, this is mostly what I wanted to talk about. To summarize really quickly what we can do for LCA and robotics and why it's useful. So to go back to this data collection point really quickly, often when we have robots, we have a lot of discrete technologies and some technologies that are being newly developed. So we might take something that's already existed and modify it for a robot. And then, for example, in that case, we can just focus our life cycle assessment on the new parts of our technology. And then we can reduce the work a little bit. Another thing that's always a thing or often in a life cycle assessment and robotics is that the use case makes up for a lot of the impacts. especially the carbon emissions. But sometimes when we develop new robots, we don't exactly know how they will be used or how the deployment will look. So maybe we can focus on building scenarios that will show how the usage will actually be of the robots. And yeah, for a bit of a motivation or a reminder, the life cycle assessment can help, especially in the early stages of development, to identify hotspots of a new product environmentally and aid in finding improvements maybe in the design for building a more environmentally sustainable product. And it can help broaden the perspective beyond just energy efficiency, look at other impact categories, see how we can improve, especially with novel materials, and yeah, give pointers in that direction. These are some sources if you're interested in further exploring the topic of LCA and especially LCA in early technologies. And that is it. Thank you very much for your attention.
Yeah, thank you, Paula.